looking at this code review here for this GitHub project. Mercurial here. Oh, yes. So this is the original. This ChessConsole chess engine. The person is like, it's the most perfect C++ code ever, which is more of a, I believe, an aspirational statement on his part, a troll to attempt to get people to review it. But review it I have, and in truth, it's certainly not the worst C++ code I've seen, and far from it. Actually, it's not too bad. I do have a number of criticisms of it, and I haven't fully gone through all of it. I've gone through parts of it. One of the things I have done is I have made it compile under Linux using CMake, and I have verified that indeed it will run that way. And I also have made some slight formatting changes that showed up all funny in my code editor here, CLion. And the reason why it showed up all funny is because he used tabs instead of spaces. And like any decent human being, I have my tab stop set to 8 because that has been the default tab stop since the whole idea of tabs were invented for display screens. And the person who decided that for their own short-term convenience they were going to make the default 4 in their stupid MS-DOS IDE was a total idiot and a complete jerk to everybody who came after them, because they created such confusion that tabs became utterly useless. You can't rely on tab stops being a particular thing. Some people might be using 4, some people might be using 8. There's no marker in the file that tells you which is being used. And the formatting ends up all broken if you use the wrong one. Tabs are useless, and nobody should use them for anything. That's a little strong. Places like this, maybe you can use a tab. It isn't that big of a deal if it's off by 4 spaces. The other thing is 4-space tabs are actually too short for tabs to be useful. The whole goal of tabs is to make it easy to send things to a particular column so that they all line up. If they are 4 spaces, then you only have 4 spaces of difference between one that uses 1 tab and one that uses 2 tabs. And as soon as you start using 2 tabs, the usefulness of the tab stop goes down. And so 8-space tabs allow a much wider variance in what you can do for the. Also, CLion has a bug where it will not take input focus properly. I have focus follows mouse turned on here, and that doesn't work very well with CLion. It wants to be clicked on before it will believe that it has focus, and it's kind of annoying. But anyway, 8-space tabs allow a fair amount of raggediness here to be dealt with appropriately by tabs. 4-space tabs allows for a lot less raggediness. So nobody should use 4-space tabs. But because some people do, it makes tabs useless. It's very sad. But anyway, that being said, that rant over. Hello. I'm ranting about tabs, but really I'm reviewing this piece of code. And it originally used tabs. So, that being said, I had to do a few other things. And actually, I think I will go and look at... can I do that here? Can I, pick this guy and this guy? I also had to change the encoding in one file because he used a Windows 1252 character in one of the files. MSVC brain rot. But I'm not going to really blame him for that. The person who wrote this is intermediate level, and So, that's not what I want to do. What I want to do is I want to compare two revisions. I have not used this tool to do that. And no. Oh, another thing I did is change the includes. But we'll do this. Let's see, show diff. There we go. So, here are a bunch of the other changes that I made to get this, mostly to get this to compile under Linux. Hey, stop that. Yes, the tab key. I hate them because some idiot MS-DOS developer decided a long time ago, oh, tabs are much more convenient if they're 4-space. I can just use a single tab for indentation. I'll just make 4 spaces the default tab stop instead of 8 spaces like God intended from the very beginning. And once the tab stop is no longer a standard size, it becomes useless. So anyway. So I've added, like here, he was using use pre-generated magics, true. Oh, I caught a change that I didn't need to catch, so this is not an important change. Let's see here. What's the... How do I switch to the next change? This. There we go. This is another file. I'm going to have to... okay. And then we're going to do this. Does that get... No, that doesn't get a diff. Okay, we're going to go through this way. So here he's assuming that int max and int min are available as macros. They aren't necessarily on all machines, especially if you prune the include files. So I just did this. You should be using this instead anyway, not int min and the int min and int max macros. Should be using the numeric limits. And so there, I set that up, that change, and then let's go through the other changes that I made. Again, using int min, int max. This is a little bit ugly, but I just did the same old replace. Oh, I just discovered a mistake that I made. Well, that's good to know. I'm going to have to fix that. That probably explains why the chess engine is in fact doing the wrong thing. Because I noticed that it's playing poorly, and I wasn't expecting it to play poorly. Oh. Well, one of the things he claims is that he's really careful about types, but I don't agree with him. And using int min and int max and base int, maybe. I don't know. I don't disagree that always using base int is the wrong idea. But I don't think that he is using types appropriately. He's using size t in places where it's in fact not appropriate. Just because he wants an unsigned value, or he's using it to index into an array. And that's not necessarily a good enough reason to use size t. So, think. Anyway, I need to fix this error. Not sure what to do about that. This error is in engine.cpp, so we'll switch to engine.cpp over here, because I don't want to miss this error. There we go, engine.cpp. And we're looking for min-max here. And here it was int min, int max, and I accidentally used... No, not this one. Okay, we're going to have to search through for min-max. Or mini-max, that's right. So this is where he defines it. And next down, use it here. Is this the... Nope, this isn't the right one. So next one. Nope. Again, that's not the right one. No, no, no. Sorry. This is the right one. And it's supposed to be, this one is supposed to be max and not min. I'll make this change here because I caught it while I was looking over the diff. I'm glad that I looked over these diffs to try and explain them to everybody else. You always find the best things when you're trying to explain things to other people. Oh, yeah, I guess that's true. 2-byte ints. That's an old problem to have, though. I actually used to write programs for machines that had 2-byte ints. But it's hard to find machines like that anymore. I actually wrote a little bit of C code that was designed to compile on an Atari 8-bit machine. So I think the min and max there are supposed to be the min and max. So Minimax is an algorithm that goes through and keeps on trying to minimize or maximize the utility, the goodness function as it goes through game moves. And so I think the min and max are there to track the like this actually gets turned into whatever the best one it finds is, and this one gets turned into whatever the worst one it is. So you want them to start out as being worse than any possible one and better than any possible one. And so that's why he's going for int min and int max here. So yes. Anyway. And minimax, oh, it won't bring the definition up just because I mouse over it, which is sad. But if we go up and look for it up here, what does it actually take as arguments? State is something about the state of the board, which also includes a bunch of things. And then depth is how far deep it's gone, and alpha and beta are ints, so int min and int max are appropriate here. And they're, I think, something about, I think it'll turn out that they are something about the evaluation function for the goodness of the position. So anyway, I found a bug, but I had to replace int min and int max here with things from numeric limits. And I shouldn't have used decal type depth. I should have just used int, because in fact it's not about the depth. Okay, I'm going to have to fix that problem too. All right. Probably not this one. Not that one either. This one. You know, I should have read the code more carefully before I put stuff in here. Now, I don't think having it be decal type depth is a bad thing. I don't know. I think depth might in fact be an int, but it might also be an unsigned, in which case it is a bad thing. So we should use int here because in fact the parameters alpha and beta are ints. So much for me trying to be too clever. Anyway. Then he uses the system thing to clear the screen, which is a very Windowsy thing to do. I must be in the Windows environment. I'm going to do this. Also to calls out to system inside of a program are a huge red flag, because that's the hallmark of a piece of malware. So I removed it. There are better ways to clear the screen, and I might put them in later. I actually personally don't care if the screen is cleared before these board prints, and so I just removed it. Then he mixes up the use of steady clock and high resolution clock, assuming that the same thing as system clock and things. So I had to go through and just decide, okay, I'm going to use the same top clock type. I think on my system, I didn't check exactly what the accuracy is, but I think steady clock had too low of an accuracy to be useful for what he was using it for. So I switched it to high resolution clock. And I needed to do that to get it to compile, because mixing up the clock types worked fine under Windows, because high resolution clock and system clock, or whatever else he was using, steady clock I think actually is what else he was using. High resolution clock and steady clock were the same, and under Linux they are not the same type. Which is again, this was actually a bug. This code would never have worked, and so I don't know what his little compiled executable that he shipped with the program was, because in fact he did ship it with a compiled executable. And so, but this is a bug. It didn't compile with this because the pawn attacks. There's two versions of this function for what color the pawn is, and the index pawn attack one there that doesn't exist. There's pawn attacks, and then pawn attacks is in fact a two-dimensional array indexed by the color and then the square. Basically, this is a pre-generated array describing pawn attacks, which I don't know exactly how it works right now. But I was able to divine that, in fact, this is what it should be. Probably. I'm not absolutely positive. This compiled anyway, once I changed it. And then next file. Don't need I needed the bit header, because we'll go to other changes in this file and you'll see why. He was using built-ins that were MSVC specific, in particular pop count 64. But of course, C++20 actually added versions of these functions that are standard, which seems a little complicated for a simple concept. This. The pre-generated pawn thing? I mean, I don't think so. He's trying to make his engine fast, and having some kind of pre-generated map of where pawns can attack, I can actually see being a very useful thing to have. Like, if a pawn is on this square, what are its attack squares? I want a bit mask of its attack squares, and I can see that. Bitboard is basically a bit mask of a board. We'll get to that later. And as I said, I can see that. Like, why would you want to go through all the math of, like, oh yes, pawns can attack diagonally. I have to, like, oh, but it's a black pawn, so this one I have to subtract the file, and the other one I have to add the file. And you want to do that math every time you're going to calculate pawn attacks, when you're like trying to zip through as many possible positions as possible. Yes, I think actually having a pre-generated bit mask like this is really great speed optimization, because having to do all of the calculation to figure out where the pawns are supposed to be attacking every time you're doing some kind of move evaluation doesn't seem like a wise idea, because it's going to be the same every time. Why not just pre-generate it? I will get to his pre-generation. I think he's pre-generating it when the program starts, which is the wrong approach to take in modern C++. You can pre-generate it at compile time. He might even have a special executable that prints out code or something. I don't think he does that, though. But, yeah. Anyway, so here he's using all these bit functions. And so I include the bit header so that I can get the standard versions of the functions, and I can stop using the MSVC specific built-ins, although I believe that this particular name is available with the right incantations on GCC as well, which is the compiler I'm using. I'm not sure. Doesn't matter. I don't want to use that. I want to use the standard. So I use the standard. That does make it so that this only compiles with C++ 20, though. It won't work on C++ 17 because they hadn't added those bit functions yet. And again, with the pop count and replacing it with standard pop count. But then there's and I do it here too. I actually did a search and replace on that. So then I'm going to go to this one. Again, this is the intrin.h is the one that has the MSVC specific bit intrinsics. And I removed that because, I'm not in MSVC land anymore. And also, they're not even used in this file. He has all kinds of includes all over the place that aren't actually used. One of the nice things that CLion does that actually will tell you about that. Oh, this is a bunch of stuff where I'm fiddling. I'm using Mercurial. Mercurial doesn't like the not prefix for gitignore. Mercurial will pay attention to a gitignore file instead of an hgignore. Hgignore is really flexible, but I do not think that it supports the not either. And it doesn't actually even matter here. So, because this is basically a boilerplate gitignore file that MSVC generated for him, I think. And has all kinds of stuff that are not relevant to his project. Anyway, I removed everything that Mercurial doesn't like from the gitignore file. But I also added a few things to it. The things that I added are the IDEA and CMake build directories, which are there for IntelliJ and friends like CLion. And this is something CMake puts in. Anyway, that was that. And not a very important change, honestly. This is a diff. I removed executable, and here we go. This is my new CMake file. Simple enough. Okay. Then target level properties instead of global. I missed a change. There's a change in here for a... there should be a change in here for one of the bit intrinsics that got missed. Anyway, he's using a bit intrinsic to find the lowest set bit, and I changed that too. And it's not in the pregen file, it's in some other file. MoveGen. It's not in MoveGen. It's in Bitboard is where it is. Not an engine. Huh. There we go, Bitboard. But not bitboard.h, bitboard.cpp. There we go. Yeah, this one, bitscan forward 64. Count R0 does the same thing, but is, yeah. I don't know that it does the same thing, actually. I should really look at what bitscan forward 64 does to make sure that it does do exactly the same thing. Because maybe this starts from the high bit and scans down to the highest set bit and tells you what its index is. Is that what it does? Or does it start at the lowest bit, the least significant bit, and scan up backward, I would call it. But of course, if you're doing byte reversed architecture like the Intel, it might be, and count R, I'm pretty sure it starts at the end and counts backward. And yeah, I don't know. I don't know whether this is correct or not. Anyway, bitscan forward returns a true-false value about whether it succeeded in finding it or not. And this thing returns size max if it didn't find it. Otherwise, it returns the index. And so I had to, figure out what the max was by this should be. I don't know if I made this const expert. I should have made this const expert because this should be computed at compile time, and then I can just compare against the. Oh no, the index can't be, but the max can be, and the max is const expert. That's good. And so then I compare I basically replace this logic, but I'm not completely sure that bitscan forward is the same as count R. Maybe it should be count instead of count R. Does bitscan forward find the position of the most significant bit or the least significant bit? And then does count R find the position of the most significant bit or the least significant bit? I think it's supposed to find least significant bit, find one LSB. Yeah, this is supposed to find the least significant bit. So apparently bitscan forward 64 finds the least significant bit, which that's what count R0 would do. So, yeah. It would find the least significant bit. So I think, given the name of the function, that's what bitscan forward would normally do, is find the least significant. Which I think it's given a terrible name. Because it's given a name that's specific to a particular hardware architecture rather than to the mental model that most people have of most significant to least significant. So anyway, that's that change. Now let's go target level properties. This is just a change to the CMake list file because I didn't like doing this. This is probably what you should be doing instead. I actually maybe need to look at the minimum required CMake to support this. I think CMake 3.16 is late enough. I have a tendency to look at what CMake I'm using and set it to that, but really I should be using a minimum that's like, if everybody has a 4-year-old CMake, what version do they have? Anyway, that's that. I don't know if you've ever used CMake or not. I had to learn how to use it when I worked on Minecraft briefly, and I had to learn how to use CMake because they wanted to move their build system to CMake, the Bedrock edition. Again, only need C++ 20. Yeah. I had a very complicated makefile that used Perl and all kinds of things to extract dependencies from the build and then put those reread those dependencies when doing a make again so that headers were included and all of that stuff. But CMake does that for me. And it's a much simpler syntax, and I don't have to maintain a custom Perl script that gravels through the output of GCC to look for the things that I want. So I use CMake now. Also, it integrates with things like Conan and stuff like that. So if ever I want to make packages that are relatively easy to use for other people on other platforms, I guess CMake it is. I think it's kind of ugly, though. Anyway, I originally was saying C++ 23, but it turns out I only need C++ 20. Yeah, this is a space-only change, so we're going to ignore it. This is the one where I was ranting about tabs. And then this one is changing it had a non-breaking space and was using the Windows 1252 version of the non-breaking space character. I actually removed the non-breaking space at all. Like, there's no reason to have a non-breaking space in here. Yes, it wasn't in UTF-8. That's why there are errors. And then this is where I remove all the unnecessary includes, and then I put the includes. Like, he had a bunch of includes in header files and then was relying on them in the CPP files, which is bad practice. You shouldn't be doing that. Yeah, I have my own libraries, but I want my libraries to be easily consumable by other people, which is another reason to use CMake. So, anyway, as I said, He had a bunch of header files being included in header files that were then being relied on in CPP files. And that's not how you should be treating headers. You should include exactly the headers you need for the declarations that are in the file that you included the header for. Honestly, I can't wait for C++ modules to be a widely implemented feature because I vastly prefer C++ modules. So let's see here. So we're going to close this diff. And we're going to re-equalize the sides here. Okay, we're never going to make them totally equal, but this is close. Anyway, now we're going to get to more of the meat of the change that I wanted to make. Oh, and there was a problem I found. No, this was right. Is there something else? Oh, I was worried about the bit count thing, but I determined that, in fact, he was looking for the least significant bit, which is what countr does. Because that's what he named his function. And I presume that his function name reflected what he wanted to do, so I do not have to go look up that bit thingy from the MSVC manual to find out what it really does. Okay. Anyway. So we're going to get to this bitboard thing. So this bitboard is a really interesting idea. And I think he got it. He was following a tutorial on how to write chess engines. And I think this tutorial suggested this idea to him. And this has a whole bunch of problems with it. But it also is pretty nifty. So the idea of bitboard is this is basically a bit mask for the entire board. You have 64 squares on a chessboard. Why not use a uint64 for it? And so then there's like 12 different pieces in chess. I mean, you might think there's 32, right? There's 16 per side, but in fact there's only 12 unique pieces because there's a pawn, there's a king, there's a queen, there's a rook, there's a bishop, there's a knight, 6, and then you have white and black, so 12 different pieces. So he basically, the bitboard is a mask for a particular kind of piece. So all the black pawns would be one bitboard. All the white pawns would be another bitboard. All of the white bishops would be a bitboard. All of the black bishops would be a bitboard, showing the positions, of course, of those particular pieces. So that's kind of a nifty way of representing a board in a reasonably compact fashion that still allows easy access to the thing that you might be looking for. Like I can think of more compact representations, but those more compact representations would be expensive to unpack as you were trying to, figure out things about the board. So this is a reasonably compact representation. Problem is it's a bit set, right? It's not a uint64. It's a bit set, and there is a perfectly good bit set. It's called bit set, right? And so why not just use bit set? I have a 64-bit bit set, and I double-checked in Compiler Explorer, and a 64-bit bit set is 8 bytes, just like you'd expect. That's how big it is. So it's exactly the same size as a uint64T. And so that's a problem with this. This should be using a standard bit set instead of a standard uint64T. Then, all of these functions are not inline. And these are like functions that are used constantly by the low-level chess engine when doing board evaluations and generating new move sets and things. And why they should be a inline, most of them. This one, I don't know whether I want this function in there or not. So I don't know if I'm going to make this change right now. If the guy whose code I was reviewing was here, I'd make these changes in front of him. But he's not, and I don't know that I want to make them right now. But that's a problem. All of these functions should be inline. They're part of inner loops. Also, too, I guess another thing that I'd want before I made them inline, just to demonstrate, I'm nearly positive it would be a huge speed advantage if they were inline. And just to prove that they're not inline, like you go here to bitboard.cpp, right? Here's the functions, right? And they're so simple, right? This should be an inline function. And this should be an inline function. In fact, there's a bit, and also too, if this is a bit set, there is a bit set function that gives you the pop count without calling it pop count, which is a somewhat obscure name. It just tells you count, I think, which is supposed to be the count of the number of one bits in your bit set, and things like that, right? So we don't need these. These should be inline. But what I would really want to do before I made them inline, just to demonstrate why you want them to be inline, is I would want a benchmark that runs the chess engine through generating all the boards to a depth of like 3 or something, or generates as many boards as it can possibly generate in a certain time frame. One of the two. And then like change them all to inline and then find out how the benchmark changes. Just to sort of demonstrate that, yeah, hey, you'd make this change, suddenly your thing gets a lot faster, and we can quantify exactly how much faster it gets. So then there's this move list. What is a move list? It's a vector of moves. And then there's move gen, which describes a move. Where's move? There we go. There's move. And then here, like, you're doing all these, like, you have these constants for the shifts. One, of course, this is all in the default namespace, right? This should all be namespace. Once you start having this many symbols that are at basically global level, you probably should start namespacing them. But then the other thing is why do you even have all of these? This can be done with bit fields. And I also verified that. I actually have that verification right here. Like, here is a class that does all this stuff here that he's doing with all these masks and things. Here's a class that does it as a bit field. And when you do it this way, like, the compiler can generate code that's just as efficient, probably even more efficient, because you're being more explicit about here's what I'm doing. Whereas when you're doing it with the masks and stuff, well, the compiler just can't do anything but apply the masks and do the stuff that you tell it to do, because it's harder to discern that, oh, what you're really talking about is you're treating this set of bits as in your integer as a separate entity. And if the compiler knows that, maybe the compiler can do some things to make that a lot faster. Like, actually, this value mask is 8 bits long. It should probably be the lower 8 bits. Like, if you have it stored in the AX register, or the EAX or RAX register, then you can look at, AL and see, oh, that's my value mask, right? You don't have to do any kind of masking at all. Well, no, I don't think mask rows are a good idea. I avoid using number defines at all in C++ code, if at all possible. I mean, yeah, maybe. I don't know. I mean, again, just make it inline, right? Why do you need a macro? That's not what I actually don't like macros. I don't want to use macros in C++ code. I want to make as little use of the preprocessor as I can possibly get away with. Because the preprocessor operates at a different semantic level than the compiler does. It operates at a level of text. It treats it's where the notion of compilation unit comes from. And the notion of compilation unit was a really excellent idea when C was invented. But over time, it's clear that that's a barrier. It makes C++ code a lot more confusing than it needs to be. Like, other languages have modules, and the modules have names that correspond to the file system layout and things like that. And that is a system that a lot of people find very convenient to work with and use. But once you start having this idea of compilation unit and includes and the preprocessor and all of that, it suddenly that way of looking at it doesn't work anymore. You have, I have my include directories, and if I use single quotes, it includes it from wherever the source file happens to be. But if I don't, then it goes through this search path that I have to provide the compiler on the command line. And it's just, no, I don't like that. I think it's one of the things that's a huge barrier for a lot of people who are learning C and C++. And so I would prefer modules. And modules don't have the notion of a compilation unit, but then once you've compiled your module, when you import the module, it's no longer a compilation unit, right? It's you're importing a module, and it doesn't do any of the macro stuff. And then, since the macro is a textual replacement, it interacts very strangely with scope and other C++ constructs. Like, it doesn't fit into the language at all. It operates the same way inside of a namespace as outside of it. It introduces names at global scope that, in fact, are not identifiers or anything. They get replaced by the preprocessor with other text at compile time. And again, that's kind of confusing. Like, C++ already has templates, and it has the language, it has all these other things, and then you have to learn about this preprocessor thing that does things in a completely different way than all the other parts of the language do. Like, no, I don't like it. And so I avoid using the preprocessor if I can. There are places where you almost have to, like ifdefs, for platform-specific code and stuff like that. Like, you almost have to use the preprocessor for that. There's only so much you can do with having variant header files. And there are other cases in which the preprocessor might be a good idea. I can actually see some cases where you might use macros, although in my opinion you should undef the macros after the compilation unit is over. Or after the file is over. The macro should never cross over into being evaluated into a different file from where you define the macro. Yeah, but then it is a copy-paste symbol. I kind of agree, but then that's a very weird thing to have as part of your language. It's not. No other language works that way. I don't like them. Anyway, I missed an include that I should probably have removed. This did not need move.h. Oddly enough, even though it's a move generator class. So let's look at move.h again. So it has these things. This is this class is actually a bit field, right? I have a friend who's sending me stuff, so I'm going to look at what my friend is sending me. And I'm also then going to mute it so it stops making noise for an hour or two. There. All right. And you look here, I have this definition for the bit vector, or for the bit set, not bit set, it's not a bit set, the bit fields here, and you look at the size of the bit fields and it's 4 bytes. Just like this thing is a uint32, right? And so the compiler is able to look at the bit fields and do the right thing. And so this should be using bit fields instead. And again, some things are inline here, but in fact, most of this should be inline. Like you look at move.cpp where all this stuff is defined, and you look, and these functions are really simple, right? These should be inline functions. And lots of static tasks and all static casts and all kinds of stuff like that. Of course, piece is an enum. There you almost have to use the static cast, but that's okay. Yeah. So move here should be a bit field class instead of this, and again should be using inline functions. Move gen. So now we're getting into things where I'm not completely sure what's going on as we're moving up the abstraction stack. I have not analyzed carefully to know exactly how the engine works. This looks more or less okay. One of my big complaints, and actually this is a complaint that can go back to Bitboard, right? So let's go back to Bitboard and look at this. Why the heck are you using a size t to represent your rank and file, right? Those should be uint 8s. Your rank and file are going to be from 0 to 8, right? And so you might as well use uint 8s. And if you did, the compiler might be able to do things like, oh, you're passing in two uint 8s, I'll put it in AH and AL. And there you go, it's inside one thing. And if they're in AH and AL, well, all the multiplications that you're doing to try and find out where the thing is in your bit set and all of that, well, they become trivial. You don't have to do any kind of multiplying, or you just do a little bit of a shift, and you got it. I think it might be a good idea to use a uint 8 for these instead of a size t. Size t is too big, and I can understand. Oh, it's an array index. Array indexes are supposed to be size t, but you're indexing into an array that's 64-bit, 64 entries long. So no, it doesn't need to be a size t. So there, that's that rant. So this, we're getting a little far afield. I can't adequately review this. This interface does look nice. And these functions are big enough, like we look at movegen.cpp, that there's no good reason to have them be inline functions anymore. Now, why it's a class, I'm not completely sure, but we'll see. It also has this pregen thing. I don't know that pregen should be done the way it is. This looks to be just a bunch of arrays. Why are you making a copy of all of these for each one? Like, that's what it looks like you're doing. But these should all be like static. They are consts. They're static consts is what they are. You didn't make them static. But they never change. Like, it's not like you update these pre-generated things after you generated them all. So I have to look at how these pre-generated things are made, but I kind of don't agree with the way this pre-generated class works. I think that this pre-generated thing should, in fact, do all of this stuff at compile time, and they should all be const expr things that get initialized at compile time. And maybe you want them all inside of a class, but then you just look at you treat the class as a namespace. Maybe they should all be inside of a namespace or something. And you look at it that way. I think making a copy of this pregen thing ends up copying all of these members that don't change. And then he has two copies of these members, right? He has the private copy and he has a public copy, and all of them get copied every time you make a new pregen. Like, that's expensive. What are you even doing here? I think that there's something broken about the way this pregen thing works, and I would have to look at the code a little more carefully to figure out exactly what. But the general idea of having all of this stuff be pre-generated seems like a pretty good idea. Like, you don't have to look up where a bishop that's situated in a particular space can attack. You can just get the bitboard that describes the places the bishop could possibly attack given its position. And that seems like a perfectly reasonable thing to do. So, yeah. So move list creates a pregen, like it has a member that's the pre-generated thing, which is a copy. But then again, how many move lists do you have? There's probably only one move list. No. Does the move list, it looks like it's a vector. There's pop move, find castle move, sort move list, move compare. So I don't know how he keeps track of the tree of moves, because the moves are going to occur in a tree, right? There has to be a parent, like you have to have a move that came before this move. And so I'm not quite sure what happens there, how that works. There's nothing in the move class that says, how to point at the parent. This again doesn't look terrible. This is movegen. This is the pregen, the move generator. Again, I have to know how it's used. Then let's look at We have move gen. We have a move list. I hope we have a move list.cpp. Yes. So there we have this. Find move. Find castle move. This is where I actually have to truss it up and probably run it to find out exactly what's going on here. Again, he's using inline functions here, and why are you using inline functions? This is a big inline function. This is not the proper, I don't think this is the proper place to be using an inline function. You should have been using them in all your low-level classes. That's what that's the kind of thing you do in a low-level class. As you're wrapping an abstraction around like an int64, you should be doing the, yeah. Yeah, I mean, if you love the preprocessor, why not use it for Rust? The Rust people would scream, of course, if you started using the C preprocessor for Rust, but you could. Why not? You get macros in Rust. Maybe you should swap out the C preprocessor for M4. It's like certainly a heck of a lot more flexible than the C preprocessor is. Anyway. Pre-generate magics. Bishop magics. What are these magic numbers? Are these, I think what these are is like the attack things for bishops and the attack things for rooks. I'm not positive, but that's what I'm guessing. Let's look at this number and find out what this number looks like. And let's check sub 2 colon and then no, I don't think. It might be what's going on. Let me check something here. First of all, I need to do this backwards, right? I need to do range 64, not 64. Oh, -8. That's the reason why. There we go. That's a little bit better. There we go. That's better. Okay. So no, interpreting the thing as a bitboard doesn't give you a good read on what's going on here. Yeah, witchcraft. Where the heck do these things come from? What do they mean? There's not even a comment. This uses a namespace here. There should be code that generates these, and it should be generated at compile time, so that you know where these numbers come from. There's too much magic. And my guess as to what the magic meant was wrong. So definitely too much magic. State refers to the game state, which is partly the bit boards for all the positions. I'm not quite sure what occupancy is about. um, and who's going to move next, and whether there's a square that can be captured en passant, whether you can castle to the left or the right, which is actually two things. This should be a bit field. In fact, actually, you could. I don't know if you're aware. You probably are, given the questions you've asked. It sounds like you have a fair amount of experience. But one of the things you can do is this. Right, is you could do. And then you can just do castle right, castle left, and so on and so forth. Just have an anonymous structure there. That's perfectly legal. In fact, actually, here I wouldn't have the trailing underscore. I would have the trailing underscore here. But yeah. And also, too, of course, my favored naming convention for member variables is the trailing underscore, not the m underscore prefix. I think the m underscore prefix is kind of ugly. The trailing underscore is kind of understated, but still noticeable. So I like it better. But again, I'm not quite sure what occupancy is about. But this is where, like, I think the position evaluation functions and stuff are. This is also where the things that parse a string into a board state show up. Which, yeah. I don't have a lot to say about this right now. It doesn't look terrible, but once I change a bunch of other things, I might come back to it and go, yeah, this isn't the right way to do it. It should be done in a different way. One of the other things is all these output functions. One, never ever use endl. Ever. Well, okay. There are some very limited cases in which endl is a good idea. And you should never use it unless you know for absolute certain that you're in one of those cases. Otherwise, you should just use, single quote \n, single quote in that case, or double quotes in other cases, or just include the \n inside the string. Any of those is better than endl. No flushing. Flushing is for toilets, not for streams. It's actually something that irritates me about a lot of early C++ things. A lot of C++ tutorials out there, things that taught people C++ way back in the day, used endl because the tying to I/O streams didn't work quite the way people expected. Like, it didn't flush the output stream until you tried to read some input, and then it would flush the output stream before it read the input. That used to be the way it worked. And then they changed it so that basically it flushes the output on every output operation. Anyway, if you're writing to C out. Yeah, I can see that. I don't really like I/O streams for a number of different reasons. Another reason is that the I/O streams header is extremely expensive to use and leaves all kinds of clutter in your program, because every place you include it, there ends up being some kind of static initializer thing to try and make sure that I/O streams get initialized before you use them, no matter what order you include things in which files and what the linker decides to do. Because C++ doesn't guarantee initialization order between source files. Yeah. I would actually rebuild. I would use the low-level operating system primitives for read and write a completely different abstraction over the top of them than I/O streams. I think I/O streams was poorly conceived and Strusup was like, "Oh, hey, I can overload operators. Let's try and make something based on overloaded operators that works really nicely." And I think that was a ill-conceived notion. It seemed like a good idea at the time. So anyway, that's the other thing, is using cout directly. Like most of these things, you should be passing the O stream that you want to output things to into the function, and not using cout directly. Is digit. Okay. And we have the engine, chess constants, which is all this stuff. Again, this probably should be in a class. I don't agree with naming these things with capitals. It should be in like a namespace or something, and you should use ordinary, non-capitalized names for them. Because that's reserved for preprocessor defines, and you shouldn't be using, in my opinion, the preprocessor. I suppose not knowing that anything about I/O streams is kind of a nice state to be in. File max times rank max being 64. I mean, yes, and so on and so forth. Like, these aren't too bad. This is one where I had to change it to not use int max. And then an array of arrays. This is basically a list of who it's beneficial to capture by piece. But of course, it's apparently much better to use certain pieces to capture certain pieces than it is to use other pieces to capture them. I don't know whether this is queen or king. I'm not. Here we go. So we have 0, 1, 2, 3, 4. That's queen. So the king is considered more valuable than the queen, which is correct. It is, although its value might be more considered infinite. But I suppose as you're evaluating checks and things, then you might actually consider there to be a value for the king, for putting the king in check. No piece. Interesting. So there's no piece capturing no piece is worth 61. Why is it worth so much to capture no piece? Or maybe there's a comma and then an implied 0 here? Maybe that's what's going on? I don't know. Anyway, this is an interesting thing. This is one where I can actually see the numbers not being generated from anywhere. That you just stick the numbers in here because they're kind of parameters for your engine, right? Like you could tweak any one of them and change how your engine functions. This enum is probably a good idea. I would make it an enum class, and then make it a uint 8 underlying. But that's just me. And then having this table where you can look up the piece by the letter. I mean, that's not a bad idea. Although I would actually make some functions for this and wrap a function around the search. I don't know whether he does that later or not, but I would do that. This not too bad of an idea. This is the function that creates it. This is the initializer. Okay. Could have an immediately invoked lambda there. You don't even have to have a name function. But yeah. Piece count. The other way around. That's a good idea. Although I don't know about making the black pawn be an X, but that's what the decided to do is make the black pawn an X instead of a lowercase p. Perhaps the lowercase p and the uppercase p don't look different enough from each other for him to be have been happy about that. And then this is something that should probably, in my opinion, have been generated. Also using string values here, bad idea. This forces these things to be pointers. You could actually make them standard strings and do a const expr initialization, and the small string optimization will cause the each one of these things to take up like either 6 on GCC it'll be 16 bytes, on Clang it'll be 24 bytes, and then you'll just have the A8 right there in that spot in memory, and that's great. Avoids an indirection and all kinds of things. I don't know how important that is, though. I don't think that this gets used in any tight loops or anything, and so it doesn't really matter whether it's a string value or an embedded string, but it should be an embedded string. That also means that he does this thing, includes string view, and then does using namespace the literals, so he can get all the literals in a header file, which I don't know. Again, it should be namespaced if you do that. Because you don't want to do that for everybody else. Castling rights. Not quite sure how this works, but okay. Standard array, white pawn, piece value. Okay. -0 for the black king, but of course it's not. It's an array of ints, so there is no -0 in integers. Things about what the bit values are for the castle. I don't know how I feel about these using enums in this way. I don't know how I feel about that. My opinion, the enum should be what bit position it is, and then you can then initialize a bunch of other constants to have the appropriate mask if you want. That, in my opinion, is what you should be doing. Yeah, math out the MASCII value. I mean, that's a good idea. But then again, I would have the function that did this be a compile time function, a const expr function to get all these values out, and then I would have it return a standard string and then initialize this array from it. Although I guess that's probably what you're saying is math it out at the time the person enters the board position, is what you're saying, and that's a valid thing to do as well. Just when somebody enters a board position, you do some math on their input value and figure out what board position they mean. That's just fine. Color, white, black, that's fine. Occupancy, again, I'd make this an enum class instead of an enum, just to get the compiler to be a little more anal about types. Same here for occupancy. RF, well, that's interesting. Why this is needed, I'm not sure. And then move type, ordinary move, capture, quiet, promote. What's the difference is between a quiet promote and a promote? I don't know. And then passant, and then a double pawn forward move. Okay. Random. Apparently he needs a random number generator for something, and he's wrapping the standard one. I mean, that's fine. This is a good random number generator to use. This is the Mersenne Twister, and Mersenne Twister is a pretty high quality random number generator. Yep. Again, some of these functions could be inline, maybe. I don't know that it would really matter in the context in which the random number generator is being used. But that's and we'll look here at random.cpp. Well, that's interesting that he has all these functions that he's using. I'm very curious as to what this random number generator is being used for. Then we have engine. We had the guy who wrote this on. He can answer my questions and make things a lot faster. An engine is the thing that actually does all the board evaluations and generating the new moves and trying to have a time thing about depth and stuff like that. Again, this is what I want time to sit down and analyze this carefully as to what it's doing before I talk in detail about how I would change it or what I think is wrong with it. None of this stuff. I also disagree with putting the private section first. The private section, in my opinion, should be second. Because when you're looking at the engine, the thing that you care about is the public interface. I suppose an IDE just tells you what the public interface is when you do dot and try to call a function, or dash greater than and try to call a function. Then it will tell you, oh, here's the functions you can use, and so then you don't ever have to look at the class definition. I don't like that. I don't like coding in a way that relies on IDEs. The private section should go second because the public part is what you care about, and it should go first, right after the class declarations. My opinion. Depth searched. Oh, these are all interesting. Duration. I'm not quite sure how duration is used. I don't have a good context to know whether these member variables are a good set of member variables to have or not. I would have to know more about exactly how the engine works. I believe the minimax function is in here. Yeah, this is probably the core of the engine. Anyway, that's about it. And then main, of course, exists and does hardly anything. Creates the engine with an initial board state. One of the things that it does that I don't understand, and it adds an extra pawn here, which I don't know why would you do that. I think that it's not supposed to do that this was a testing thing that got left in by accident. And then the engines.step. I guess the engine.step runs the whole entire thing. It's like all the steps, not just a step. That's fine. Anyway, tell the original author says something. That's all the code review I can do for now. What do you think, Paul Arthur? It's a pretty tiny chess engine. I think it has its internal. Let's look at this step function. So we have main.cpp. Go to declaration. This is where it is. Yeah, it's a while true loop, right? So there's definitely a loop here. It starts with printing the board, sets the depth to something. It's given a depth as the last argument. Whether it flips the board or not. So no flip board, false depth 8. Apparently depth 8 is the maximum depth to which it will do searches. If it plays itself, then it has this thing that it does here. If the board starts in the wait to move state, then it decides that the engine is the white side. Otherwise, it has the thinking, iterative, bin max, make move. So there must be something here where you ask the player for their move. Oh, that's if the state is wait to move, then we'll do this. Otherwise, engine plays itself. Oh, player play itself. I see. And these are constants that are set. And then otherwise, move list, generate moves, input and parse move, make move. Does not exist. I think the generate moves is done just to have something to compare to find out, is the move that the player just made a valid move? Is it on my list? It'd be my guessing. That's the reason why it takes the move list as a reference here, input and parse move. That would be my guess. Then here's where the time, there's an end time, duration, end time minus start time. Nodes. How does it decide then? This is where it actually makes, no, this is the new move. No. I think that I would have to actually step through it with a debugger to find out what it's doing. And again, I kind of want the guy who wrote it to kind of guide us through how it works. Either that, or I take the time to step through it off camera, and then lead everybody through it on camera after I understand what it's doing fully, so I don't make a whole lot of missteps. I think the motivation behind the bitboard idea is speed. Making it really easy to calculate new possible positions from existing positions. I think that is the reason why the bitboard construct exists. It is not, as I said, the most compact representation. The representation you're suggesting is a little more compact. I thought of a representation involving just having, like you do this. Like, what piece is in each square, right? And if you do that, right, that's 230 bits. It's not that many bits. And even if you do 16 to the 64th, because you're tracking each piece individually instead of tracking the piece types. In fact, you'd have to track each piece individually. Right? That's 257 bits. That's not that many bits. That's a heck of a lot less than the 768 bits that it takes for the bitboard, like 12 times 64, right? That's 768 bits. That's how many bits the bitboards for all of the pieces take up. But this one, it's really hard. It's not that hard because you're doing 16, right? So it's not that hard to pick out the individual piece from this. And this doesn't even have to be 257. This can be exactly 256 bits. And then picking out the individual piece, its board position, is not that hard. But I still think that what you would end up doing then is... and if you did 64 instead, you had board position and then what piece was there, right? 64, and then you'd have to have 4 bits per piece. So that's 256 bits, 64 board positions, and then one of 12 different pieces at each board position. Now that works. That might be just as good a representation as the bitboard. I don't know. Yeah, I don't know. I have to look more carefully at the evaluation function and the move generation function. I suspect there's a really good reason why the bitboard is being used. Because I don't think he came up with the bitboard concept himself. I think that he got the bitboard idea from the tutorial he was going through on how to write chess engines. Anyway. Yeah, I don't know. There's also, I think, in the pre-generated section, I think there's masks that describe a bishop at this position can move to all these places. And if you just AND the mask with the bitboards for all the different pieces that you have, you can then find out, is the bishop going to be colliding with any piece? It's a really quick way to evaluate whether you have a capture or not, right? Yeah. I think the bitboard I think the bitboard idea is probably a pretty good idea. But yeah. Anyway, I think I'm going to end the review for now, and maybe do some more analysis, and maybe the guy will get back to me. I think I'm also going to post this on YouTube, and then hopefully the guy will get back to me, or maybe, as I said, I'll do some more analysis, and then I'll do another section of review.